This is our first lecture on financial mathematics, which is the mathematics of understanding how money accumulates in investments and loans and things like that. We're going to start off with something basic that I think probably a lot of you have seen, but just to get all the numbers straight and to get some ideas straightened away, and then we'll move on to some more complicated examples, things that you should probably know about. Okay, so we're going to start off with the ideas of simple and compound interest. Okay, so starting off first with the idea of interest. So interest is money added to an investment. An investment here is kind of broad. This can mean money that you're saving, right? Or it can mean money that somebody's investing in you that you're paying them back more than they gave you, what's called a loan. Okay? So an investment or a loan, depending on which side you're looking at it from, it's usually a percentage of the total amount. Okay? So if you think about it, this makes sense. Rather than just saying, I'm going to loan you this money, I'm going to charge you $50 no matter what I loan you, it makes more sense to say, I'm going to charge you 8% of what I loaned you, or 7%, or something like that. Okay? And so there are two approaches to computing interest. So the first one is what's called simple interest. Okay? And so in simple interest, you add on a fixed percentage of the original amount each unit of time. And generally that unit of time will be 1 year. Okay? And so if you're adding on interest over a year, you have to keep this in mind because you may have a loan that's made for less than a year or for like a year and a half, and so you have to adjust, and we'll talk about how to do that. Okay? So we add on a fixed percentage of the original amount each unit of time. Okay? So for example, if you borrow say $1,000 for 2 years at a, say, 4% annual interest rate, then you would pay back $1,000 plus 4% of that for each year that you're borrowing it for. So 4% of 1,000 for each of the 2 years. Okay? So you'd pay 4% back the first year, 4% back the second year. And so at the end, you would owe 4% of 1,000 is 40 times 2 is 80. So this becomes $1,080 at the end of 2 years is what you would owe. Okay? So we call this simple interest. It's very easy to do. This is basically the entire thing. And so we can get a formula for this. So the formula for simple interest is basically exactly what I just wrote down. So the amount that you end up owing at the end, or the amount that you have in your account at the end of the period, whether you're saving or borrowing, either way, is going to be the initial amount, which we call P. So P is for principal. If you haven't heard this term before, so this is the original amount invested or borrowed. Okay, so the amount that we have at the end is the principal plus the principal times the rate times the time. Okay, and you can see that's exactly what we did here. Maybe I didn't write it down in quite the same order, but the principal plus the rate times the principal times the time. Okay, so just a few notes about this here. Make sure that R is the interest rate as a decimal, and make sure that T, the time, is time in years. Okay, so R is usually going to be an annual percentage rate, what we call an APR. And so if this is an annual percentage rate, T also needs to be in time. T also needs to be in years, rather. T is time. Okay, so just an example of this. Say you borrow $2,000 at a 14.1% annual percentage rate, APR, for 3 months. Okay? So to put this into the formula, the amount that you owe at the end is going to be $2,000, our principal, plus $2,000, our principal, times our rate, 14.1% as a decimal is 0.141, times the amount of time. 3 months as years is going to be 3/12 of a year. 0.25 if you write it as a decimal. Okay? But that's going to be how you solve a problem like this. You need to make sure that the time is actually in years so that it matches with your interest rate. Okay? And so if we calculate this out, we get 2,000 plus 2,000 times 0.141 times 3/12, and we get 2070 50. Okay, so after 3 months, you have to pay back $2,070.50. Okay, if you wanted to figure out what the interest was that you've accumulated, that would just be the $70.50. Subtract off the principal, whatever you borrowed originally. That's the answer. Okay, so that's simple interest. This is generally not what's used in most examples. Okay, so in simple interest, we calculate a percentage of the amount that you borrowed at the very beginning. Okay, what most people do instead is what's called compound interest. Okay, and so in compound interest, we're going to charge a percentage of what you owe at any particular time. So if you think about it, if you add on the interest after 1 year, you now have whatever you borrowed plus the interest that you borrowed. And so in compound interest, we calculate interest based on that new amount, the amount plus the interest. And so it compounds, it builds up as you go along, right? And so in compound interest, say you borrow $1,000 at 4% interest, compounded. Let's do more than that. Let's do 10% interest. 10% interest compounded annually. Okay, so what that means is that we're going to calculate interest each year. So if you look at how much you owe, year amount. In year 0, you owe 1,000 at the very beginning. After 1 year, you owe 1,000 plus 10% of 1,000, so 1,100. Okay. Now, if this were simple interest, after 2 years, we would add on another $100, right? Another 10% of the original amount. But in compound interest, what we do instead is we add on 10% of this new amount. Okay, so we take 10% of 1100 and add that on, we get 1210. Okay, so this is the compound interest amount. If we were doing simple interest, we would just add on 10% of the original amount each year. So 1,000, 1,100, we'd add on another 10% of 1,000, so 1,200. Okay? After 3 years, we're going to add on another 10% of this amount now. So 10% of 1,210 is 121. So we're going to have 1,331. Whereas here, we would just have 1,300. We'd add on another 10% of the original amount. Okay? And so you can see how the compound interest builds up faster. After 4 years, we would have 14. See, this is 133, so 1464, 10. Whereas with simple interest, we would just have another 10% in the original. Okay? So just to tie this back in with what we learned before, you can see here compound interest is growing exponentially. It's multiplying by some amount each time. And you're going to see that the formula looks like an exponential growth formula, whereas simple interest is growing linearly, right? We're growing by 100 each time. Here we're growing by 10% each time. Okay, so this is exponential. This is linear. Okay? So, okay. So let's look at the formula for compound growth. So before we talk about it, well, actually, let me write the formula up and then we'll talk about what each thing means. So the compound interest formula is going to be the amount after however many years is the principal times 1 plus the rate over k. I'll explain what k is in just a moment, to the kt power. Okay, so here p is the principal, the original amount that you borrowed or invested, whichever one. R is the rate, right? So this is the annual percentage rate. T is the number of years, right? And so if you have less than 1 year or something like a year and a half, you need to think about that. Say you had half a year, it would be 0.5. Make sure that this T is in years, not in months or something like that. And then the K is the number of times we compound each year. And so what that means is that the number of times that we compute interest each year. So in our example that I was just showing you, where we had 10% interest, we were compounding annually, this would be 1. You compound once a year. If you were computing interest every month, this would be 12 times a year, compounded monthly. If you're computing interest every day, this would be 365. And yes, I know some years don't have 365 days, some have 366, but this is always 365 if you're compounding daily. If you were compounding weekly, it would be the number of weeks in a year, 52. Okay? Another one to look out for, compounded quarterly means 4 times a year, quarters of a year. Okay? So this is the formula. I'll leave it up here. Let me just show you another quick problem. Say you invest, say $1,000 at a 10% interest rate. So we already saw that if you compound annually, if you compute interest once a year, that you'll have 1464.10 was the number I think we saw on the last slide, the last board before I erased it. If you invest $1,000 at 10% interest rate, compounded monthly, okay, so meaning K equals 12, we'll see that what we get is 1,000 times 1 plus 0.10, 10%, divided by 12 to the 12, and let's say for 4 years, and write that up, T equals 4. So if we compounded monthly rather than compounding annually, what you'll see is that you actually end up with a little bit more than 1464. So 1,000 times 1 plus 0.1 divided by 12 to the 12 times 4 gets us 1489. 35. 1489.35 is the amount that you end up with. Okay? So compounding more often is going to give you more interest, because as you break it down into smaller pieces, you're adding interest on more regularly, and so you're computing interest on more interest as you go along. Okay? So if we do compound interest compounded monthly, we're going to end up with 1489.35 after 4 years. If we did compounded daily, everything else the same, you'll see it's just a little bit more. So 1,000 times 1 plus 0.10 divided by 365. 365 times 4. Okay, so still 4 years, but 365 times a year. Let's see, 365. Put this into my calculator. You get 1491.74. Okay, so if you compound daily instead of monthly, it's another $2 over the course of 4 years. Not a lot more, but a little bit more. Okay, there is a pretty big difference though between annually and monthly, right? The other thing to pay attention to is that this will grow as you go on. So if you compound daily for 4 years, that's not that much different than compounding monthly for 4 years. If you compound daily for 100 years versus monthly, the exponential difference increases as you go along. Okay, so it does make some difference over that. Okay, so what we've looked at in these problems, simple interest and compound interest, is when you have an investment at the beginning and you just let it sit until the end. Okay, in the next videos, we'll look at annuities, which are where you deposit or withdraw or make payments periodically throughout. So you're adding money in or removing money as you go along, and that's going to make the mathematics more complicated.